Hi, and welcome to another episode of Environmental Science. Today, we're talking about renewable energy and energy conservation. And you might notice we're here at Walmart. We're not here to get LED light bulbs or recycling bins though. We're here because this Walmart is one of only 2 experimental Walmarts. They're using an array of different techniques in order to conserve their energy and offset their ecological footprint. Let's take a look at some of those now. Hey everybody, sorry about the camera angle, but unfortunately there's no other way to capture this thing in one screenshot. What we have here is the Berkeley XL50. It's a wind turbine capable of creating 50 kilowatts an hour. That's going to power about 5% of what this store uses. It's capable of operating 4.5 miles an hour. Luckily McKinney has about a 10 mile an hour wind speed. It's 120 feet high and the blades scan out about 46 feet. And how this thing works, it's going to create torque, which powers a generator, which is going to give energy to the store here. The only bad thing about this is it's 120 feet high. It's pretty hard to hide here. And a lot of people in the neighboring communities don't like that. They don't want to see these windmills everywhere, which is why it's hard to get zoning approval for them. Also, if you don't have any wind, you don't have any power. Like I said, luckily McKinney has a pretty steady wind speed of 10 miles an hour, but you're limited to putting these where you have wind. Let's go take a look at some of the other resources that Walmart's using here. Okay, if you notice here, the Walmart front of this store is not exactly the same as all the others. If you notice there, those are what you call photovoltaic cells. They're solar panels. What do those do? Well, these cells here, they're fingernail thin cells capable of creating 14,585 kilowatts a year. That's enough to power 486 houses a day. What it's going to do, and these also are going to reduce the greenhouse gas. Walmart has these set up over the greenhouse area, so that reduces their greenhouse gas of 22,100 pounds per year. The only bad thing about these is they cost a lot. Any kind of technology, especially wafer thin, or like I said, fingernail thin, it's going to cost a lot. And look how much coverage that has. They have to cover the whole front of the store in order to get a usable amount of energy. Also, this store has to face south so they can get the correct sunlight. So that's going to affect your landscaping and the way you face your buildings if you're going to use these in your residential areas. And these are only good during the daytime, so if it's night, these aren't charging, so therefore you're losing some of that usability. So cost to effectiveness ratio, you got to balance what you got. So a few more things I got going here. I'm going to show you some bioswale. I'll tell you what that is in a second. Alright, now to you and me, this may look like regular landscaping, but what this is called is bioswale. What it does is it eliminates the heat island effect. Have you ever noticed in the city it's a lot hotter than it is in the country? Well, that's because the pavement reflects heat. What this does is it collects all the heat, and also the rainwater is caught in here instead of running off into storm drains and storm sewers. And this way it goes back into the groundwater and we can reuse it. Also, if you see here, this pavement's a light color. It's to keep down the reflectivity. That way the sun will go into it instead of reflecting off. Walmart also uses a white roof in order to reduce that ecological impact. So as you can see, Walmart is using many other resources here to reduce their ecological footprint. And if everybody starts doing this, we can cut back on some of that usage. Thank you.